Section 2.4. We're going to start with just one-step equations. So first of all, what is an equation? It's a mathematical sentence stating that two expressions are equal. We did mathematical expressions on our quiz where we were just the product of a number and 3x, right? That doesn't really complete the thought like an equation does. An equation would say 3x equals 15, right? And then you actually have a statement that you can solve and get an answer to, all right? And you can determine like truth value for a specific number. So it is a sentence stating that two different things are equal. When you have an equation, you have an equal sign, hence the term equation, right? A couple of things about equations. The first thing is we have this symmetric property. This is important because, one, it doesn't matter which way you write it. So if you have one thing equal to another, you can flip-flop it, okay? Sometimes this helps when you're solving because you always want your variable on one side, right? If you're the type person, I always want my variable on the left side. That's fine. You can just flip the sides and you still have the same equation. It doesn't matter which way you write them. It's also important to keep in mind that you always want to keep those sides equal, okay? Whatever you do, you can't change the balance of the equation, all right? And so you start throwing in some other properties here. The first thing they talk about is something called an inverse operation. The reason they're talking about this is you are going to use inverse operations to solve equations, all right? So this property of an inverse operation is that it undoes a property. So the inverse of addition is subtraction. The inverse of multiplication is division, all right? And so these inverse operations help you move things across that equal sign so that you can figure out what the answer is, but still maintain the equality. All right. So let's look at some of these operations that you will be doing. Addition. Now remember, subtraction is just adding the opposite. So subtraction falls under this as well. If you have two things that are equal, then if you add the same thing to both sides or subtract, by the way, it maintains its equality. You can think of it as a balance. If I have 5-pound weights on either side of a balance and I add 2 pounds to only one side, that becomes unbalanced. But if I add 2 pounds to both sides, then it remains balanced, right? And so your whole concept here is to keep the balance. Whatever you do to one side, you must do to the other. So with addition, if you add to one side, you need to add it to the other. Or if you take away from one side, you need to take it away from the other. The same thing is true of multiplication. If you start out with two things that are equal, multiplying both sides by the same number doesn't change the equality. It keeps it equal, as does dividing both sides. And they give you some examples there. All right. The example up here, x minus 17. They added 17 to both sides. It maintained the equality here. X plus 10. They subtracted 10 from both sides. It maintained the equality. They were dividing, so they multiplied both sides. They were multiplying, so they divided both sides. You'll notice that they are doing inverse operations. This was subtraction, so they did the inverse to get rid of it over here. This was addition, so they did subtraction. This was division, so they multiplied. This was multiplication, so they divided, okay? Those are the concepts we're going to be doing, which hopefully are review from your pre-algebra days. All right, so to solve an equation, find out what is happening to the variable, then do the inverse on both sides. We have this first example, x minus 12 equals 15. If I am trying to solve for x, that means I'm trying to isolate it or get it by itself. I am going to look and say, well, right now we are subtracting 12. I want to then do the inverse, which is adding 12. So anytime you do something to put it on the other side of the equation, you will do the inverse, okay? Do the inverse. Your goal here is to get x by itself. You have a negative 12 and a positive 12. Those zero out. You're left with just your x. Make sure you bring down your equal sign. As we get to more complicated ones, you don't want that equal sign to get lost because you'll forget which side of it you're on. Then you're just going to do what it says. We have 15 plus 12. X equals 27. The nice thing about equations is you can always check them. You have told me that your answer is 27. You're saying x equals 27. We just did substitution on our last quiz, right? We had what the variable equaled and we solved for what the order of operations was. In this case, we can plug the x back in. Instead of saying x minus 12, we would say 27 minus 12 equals 15. you'll see that 15 does indeed equal 15. That was a true statement, so your answer is correct. That is a solution. All right, so given the variable, you should be able to tell me if that answer is a solution by getting a true statement. All right, we start out with x plus 2/3 equals negative 7/12. We're going to do the same thing here. This is addition, so we're going to do the inverse, which is subtraction. If we subtract here, we need to subtract from this side. You'll notice with the fractions, I put it beside it, just so I can subtract across. On the left-hand side, once again, positive 2/3 and negative 2/3 were zero out. I'm left with just my x. I do need to bring down the equal sign. But now that I have fractions, what do I have to have when I'm subtracting fractions? Common denominator. What is my common denominator? 12. So the 12 is already on the 7/12. I need to get a common denominator here. So I'm going to multiply the top and the bottom by 4. I have negative 7/12 minus what? 8/12, okay? Now I'm going to do the same rules here. I have minus minus. So remember, it's adding the opposite. So I have negative 7 plus a negative 8. What is my numerator? Negative 7 plus negative 8. Negative 15. Add them and keep it. What about my denominator?
12.
My denominator is just 12. All right, once you have found your common denominator, it stays the same. You have 7 parts of the 12 and 8 parts of the 12. You have 15 parts of the 12, okay? It is negative because you had a negative 7 plus a negative 8. This is your answer, right? I will need to look for one more thing with fractions, though. Can I simplify it? All right? So you're going to say, is anything in common to the 15 and the 12?
Yes.
What is it?
3.
I have a 3 in common, so I'm going to divide the top and bottom by 3 here. So my final answer is going to be negative 5/4. And once again, you can check your answers, right? So you can say negative 5/4 plus 2/3 equals negative 7/12. Get a common denominator. Right, so we have negative 15/12 plus 8/12. That does equal negative 7/12. So that is true. This was the correct answer, right? So same is true for multiplication and division. You want to look at what you have, decide what the inverse operation would be, and then do that to both sides. All right? So I have x/7 equals negative 13. What is the operation currently happening between the x and the 7? It's division. What is the inverse operation of division? Multiplication. So I'm going to multiply both sides by 7. When I multiply this by 7, it cancels out. The inverse operation will always cancel out. I have x. I'm going to bring down my equal sign, and then I'm just going to do negative 13 times positive 7. Negative 91. Just follow your rules of multiplication and division, right? Negative times a positive is a negative, right? And then you're going to plug it back in to see, does it work? Does negative 91 divided by 7 equal negative 13? It does. All right. Also true for multiplication. I start out with 3x. What operation is happening between the 3 and the x? Multiplication. What's my inverse? Division. I'm going to do the inverse on both sides. It will always cancel. When I say cancel, what is it actually turning to? 3 divided by 3 is a 1, okay? When you're adding and subtracting, it goes to a 0 because it's positive plus a negative, right? But when you're dividing, it goes to a 1, which is what you want, a 1x, bring down your equal, and then 99 divided by 3 gives you 33. And again, you can check it. 3 times 33 does equal 99. So solving equations, you're going to decide what the operation is, perform the inverse on both sides, simplify both sides, and check your answer. That is how you will do it, no matter what the operation is. Okay, so let's try some of these. So this says justify each step in the solution of the equation. So they start out with x minus 2 over 9 equals 5 over 3. What do we need to do here? What's happening? Subtraction, right? So what is my inverse operation here? So technically I'm going to add 2/9 here and 2/9 here. Why can I do that? What did we talk about at the beginning of the chapter? Our addition property tells us we can do this. So we have these properties of equality, and specifically addition. The addition property of equality tells us if we add it to both sides, did we change anything? Did we change the equality when we added to both sides? No, it's like a scale, okay? Now, just in process, we would just cancel these guys out. We're like, oh, well, it cancels. What does it technically do? What's negative 2/9 plus 2/9? 0. So I have x plus 0 there, right? And here, of course, I am going to get a common denominator. And I can add those, right? 15 plus 2. All right. Why do we know it zeroes out? Well, in the prior chapters, we found out that if you add inverse, it zeroes out. But there's also a specific thing here. We're not just going to leave it as x plus 0. Why can we just say it's x? Yeah, because if you add 0 to anything, it's just the number you started with, right? And so we're actually using some properties. This guy is actually the identity property. Remember, your identity doesn't change when you add 0. And so what we don't realize when we're doing this is we're using a ton of these properties that we've talked about. Adding 0 to anything doesn't change the identity of it. Adding inverses makes it 0. Multiplying in reciprocals makes it 1. And so we're naturally doing these properties without realizing we're doing them, right? And so recognize the fact that you're using these properties, and as you're doing those equality properties, you have to follow them. If not, your equation will not be balanced and you'll get the wrong answer. So just pay attention that you're doing the inverse operations and that you're keeping it balanced. All right? You will also come into things like this. Now, we did just some expressions. The difference between an expression and an equation is this one little tiny word, is. Okay? Is going to represent your equal sign. So in the expressions on your quiz, you had a number plus 5. And it didn't tell you it equaled anything, right? It didn't say is 7 or is 8, right? So this was just an expression. You could not solve it. You could just say, well, that's x plus 5. I don't have an answer other than it's x plus 5. When you have something like this, they've given you an equation with that word is, okay? And so you're going to interpret it just like you did on your quiz, except now you're going to have an equal sign. And so it says the difference. What does difference represent? Addition, subtraction, multiplication, division. Subtraction. So I have the difference between a number and 10. Do I know what the number is? No. So what do I put in its place? A variable, n or x or whatever variable you want, right? The difference would be subtraction between a number and 10. And then we have this little word is. That's where we're going to put our equal sign. Is. And then they tell us what it is. It is 37. And so we have now interpreted these words into an equation, specifically an equation that we can hopefully solve. How would I solve this equation? Yeah, I'm just going to do my inverse operation. Add 10 here to keep it equal. I add 10 to the other side. On the left-hand side, the negative 10 and the positive 10 zero out. I'm left with just my variable. On the right-hand side, I'm going to add the 37 and the 10. And so then I can say, well, does the number, the difference between the number and 10 equal 37? And it does. Okay? And so I have interpreted it correctly and I have solved it correctly. All right? And so this is prepping you for word problems, actually. It's prepping you to be able to break down a word problem into an equation and then solve the equation, right? You're going to see this in science a lot. You're going to see either word problems or you're going to see formulas, okay? And so the next equation actually comes from science, which hopefully you've talked a little bit about Newton's first law. You definitely had to read about Newton when you finished your quiz. Newton's first law of motion relates the force of an object to its mass, resulting in acceleration. And they've given us, they said force is going to equal the mass of the object times the acceleration, all right? They want us to solve this formula for A. What they want is they want A to be all by itself. And we don't have any numbers here, but we're going to do exactly what we did for all of the other equations. They want this by itself. What's happening in between the M and the A? It's multiplication, right? When you have two variables butted up next to each other with nothing in between it, it's multiplication. So then I need to do the inverse operation. What is the inverse operation here? So I'm going to divide by what I don't want to have over here. I want A by itself. I'm going to divide by the M. So it doesn't matter that it's not numbers. If I do the inverse operation here, those M's will cancel out. If I divided by an M on the right-hand side, what do I need to do to the left-hand side? Divide by an M. So I end up with force divided by mass equals the acceleration. Why would I do this? Well, sometimes in science, over and over and over, they're going to want you to find acceleration, giving you force and mass. And instead of plugging it in up here and then always dividing over, you're going to just set your equation to what you're always solving for. All right, it's called literal equations, actually. And so what they're doing is they're saying it's easier if you go ahead and set the original equation into what you're always going to solve for, then you don't have to back into it, okay? And so science will do this a ton. You'll see this a ton in science, where you set it up differently. So you can say the same thing two ways. Either you can say force equals mass times acceleration, or you can say acceleration equals force divided by mass. And they mean the same thing. All right, quotient. What does quotient represent? That is division. A number. Do I know the number? No, so I need to put what there? A variable, right? Whatever variable you want. So they have a number and 15, which is just given. Is, what does is represent? It's going to be your equals. And they have told you what it does equal here. All right, so we're just going to rewrite it in algebraic form. The quotient of, and you're going to go in the same order, a number and 15 is 120. You could have written it this way as well. All right. Now, when you do this one, it's quotient, so we already know it's division. So what is my inverse operation here? Multiplication. So I'm going to multiply by 15 on both sides. Kind of a big number here. Cancel out here to a 1, so it's going to give me an x. What is 120 times 15?
18.
It is 1800. All right. Questions?